Now let's create our authentication manager. So let's right-click on the authentication demo folder and create a new file. This file will be a Swift file and we will call it authentication manager. Then let's create it. Inside of this file, we'll need to create a new class called authentication manager that will conform to the observable object protocol. At the top, after importing foundation, we will also need to import local authentication. This is the framework we'll need to implement biometrics authentication. The first thing we need to do is to get the biometry type, but first we need to create a context. So let's write private set, meaning that this variable can only be set within this class, and this variable will be called context. It will be equals to LA context with parentheses at the end. We need this context to use Face ID or Touch ID and authenticate the user with biometrics. If we take a look at Apple's documentation, when we call the LA context mechanism, we need to update our info.plis file. Otherwise, we'll run into a crash. The info.plis file, or property list, is the file that contains all the configuration details related to your application. Inside of this file, we'll also include all the keys related to important behavior of your application, for example, the usage of biometrics authentication. If you're using Xcode 12 or older, you'll find the info.plis file on the project navigator on the left side, where the folders and the files are located. If you're using Xcode 13, the info.plis file is a bit more hidden. We'll need to click on our project name, and under targets, we'll need to click on the info tab. You'll see your info.plis file under the custom iOS target properties. Hover over any key and click on the plus sign next to the key. We'll need to copy the NS Face ID usage description key and then paste it in the place of the key. If you hit enter, it will automatically be renamed to Privacy Face ID Usage Description. Leave the type as string, and for the value, you need to provide a short description as to why you need to use Face ID. For example, I will write, allow Face ID to log into the app, and then hit enter and it will save your info.plis file. Now let's go back to our authentication manager and get the biometry type. If we take a look at Apple's documentation, you can see that the biometry type is the type of biometric authentication supported by the device. And we can go into the LA biometry type page of Apple's documentation, and you can see the types of biometry available with LA context. It can either be none, which means that no biometry type is supported, Face ID, which means that Face ID is supported, or Touch ID, which means that Touch ID is supported. So right below the context variable in Xcode, let's create a published private set variable called biometry type, and it will be of LA biometry type, and by default, let's set it to none. We'll also need to create another variable, which will be private set var can evaluate policy, and it will be equals to false. We will reassign this value in the function we'll create now. So let's create a function called getBiometryType, and the first thing we need to do is to call our context .canEvaluatePolicy. We can go to Apple's documentation and you can see that the canEvaluatePolicy function accepts two variables. The first one is a policy, which is of LA policy type. The LA policy can be all of the cases enumerated on this page. In our case, we'll use the first one, which is device owner authentication with biometrics, which means that we'll authenticate the user with biometry. The second argument in the canEvaluatePolicy function is the error, but we don't need it, so we'll simply pass a nil value to the function. So for the policy, we will write dot, and we'll select the device owner authentication with biometrics. The error, as I mentioned earlier, will set it to nil. And this function returns a Boolean value, which will let us know if the biometrics are available with the current device the user is using. So let's save the result of the canEvaluatePolicy in the canEvaluatePolicy variable that we just created on line 14. And next, we'll need to set the biometry type. So biometry type will be equals to context.biometryType. And we want to call this function onInitialize of this class because we want to know which biometry type is available with the user's device. So let's create the init function and call the getBiometryType function in the init. Now that we got our biometry type, let's connect our class to our views. So let's go to content view and we'll instantiate the authentication manager as a state object. So at state object var authentication manager will be equals to authentication manager with parentheses at the end. In the login view, let's add the authentication manager as an environment object. So at environment object var authentication manager, two dots, will be of authentication manager type. Don't forget to add the environment object modifier to your preview and initialize an authentication manager for the preview of our login view. And also remember to go back to content view and add the environment modifier to our login view instance here as well. So let's go to our login view, and instead of displaying a hard-coded Face ID primary button, we'll add a switch statement. And the switch statement will evaluate the authentication manager.biometry type. Let's take a look at the LA biometry types documentation. We can see that this enum contains three possible cases: none, Face ID, and Touch ID. Therefore, we'll add these three cases in our switch statement. So the first case is .face ID, and we'll display our primary button with an image of Face ID and a text that says login with Face ID. The second case that we will take care of is the Touch ID case. So let's add case Touch ID, and we'll display our primary button with an image which will be Touch ID, and the text will be login with Touch ID. And finally, we have the case none. Instead of displaying the case none, we'll add a default case. In other words, if both Face ID and Touch ID are not available, we'll display a primary button with an image which will be person.fill, and the text will be login with your credentials. This button will prompt the user to log in with their credentials, meaning they will log in with the username and password. Now let's test out our switch statement. We'll need to run the preview 3 different times. The first time, we will build our login view with an iPhone 11 or higher. So in my case, I have an iPhone 13 and my build has succeeded, and you can see that we see our primary button with the login with Face ID button. Next, we'll need to build with an iPhone 8. This device model only has Touch ID, so you should see the Touch ID button. So you can see that we have our iPhone 8 here and we have login with Touch ID on our button, so that works. And finally, we'll need to run the preview with an iPod Touch 7th generation. As this is a very old device, it doesn't support Face ID nor Touch ID, so you should see a button with login with credentials, which is the default case of our switch statement. If all the buttons displayed are the correct ones, great. We can move on and code the function to authenticate the user with biometrics. Let's go back to our authentication manager and create a few new published variables at the top. The first one will be at published private set var, and it will be called is authenticated. By default, we'll set it to false. The two next variables we'll create will be for error handling, and we'll cover the error handling later on. So let's create at published private set var, which will be called error description, and it will be an optional string. The last one will be at published var show alert, which will be false. Note that we're not adding the private set for the show alert because we'll need it as a binding value later on, so the set must be accessible outside of this class. Then, right below our getBiometryType function, we'll create a new one called authenticate with biometrics. The first line of code inside of this function will be reassigning the context variable. So context will be equals to LA context. In other words, we will recreate the context every time the user tries to log in again. If you don't reassign the context with a new one every time, the biometry won't be checked at the next login, meaning that the user will be able to access the contents of the app straight away, and usually that's not good practice. Right below this, we will add an if statement and we use the canEvaluate policy that we assigned in our getBiometryType function. If canEvaluate policy is true, we will call the evaluate policy function, which will run the biometrics and verify that the user is actually the device's owner face or fingerprint. However, before calling the evaluate policy function, let's create a letReason variable that will let the user know why we need to use Face ID or Touch ID. In our case, it's to log into your account. Next, we'll call the evaluate policy function on our context variable. This function can be called either with synchronous code or it can also be called with asynchronous code. So let's do it asynchronously. We'll first need to add the async keyword to our authenticate with biometrics function. Next, we'll call our context.evaluate policy, and we need to provide a policy as well as a localized reason. The policy will be device owner authentication with biometrics, which is the same one that we use for our canEvaluate policy function. The localized reason is a string, so let's simply pass the reason variable that we just created. Since we are calling this function asynchronously, we need to add try_await before calling this function. And since we added a try, that means that this function might throw an error. So let's wrap it in a do catch statement, so that the catch statement will catch any error that might be thrown. We'll take care of the catch statement later on. So the evaluate policy function returns us a variable, and this variable is a Boolean value that lets us know if the biometrics authentication was successful or not. So let's save that in a success variable. And right below this line, we will create an if statement. So if success, we will dispatch queue.main.async, and we will call our self.isAuthenticated and set it to true. We need to wrap this in a dispatch queue.main.async because we cannot publish changes on the background thread and we must do it on the main thread. And since our isAuthenticated variable is published, we must wrap it in a dispatch queue.main.async. In the catch statement, we will print the localized description of the error to the console. So let's print error.localized description. And then we'll again call the dispatch queue.main.async and we'll set the error description and the show alert. So self.error description equals to error.localized description, then self.show alert will be equals to true because we want to show an alert whenever we run into an error. And finally, we will also call the self.biometryType and set it back to none so that the user can log in with their credentials and not stay logged out of their account. We'll take care of the login with credentials soon. So since we want to show an alert when the show alert variable is true, we should code that. Let's go to our content view, and on the VStack, we'll add the alert modifier, and we'll select the one with the isPresented. So isPresented, as you can see, accepts a binding Boolean value. So let's add a $, which means that we're binding this variable, and we'll call our authentication manager.showAlert. For the contents of this alert, let's create an alert. So we'll call alert, and we need to pass 3 variables. The title is required, so let's create a text that says error. The message is an optional text, but let's still add it. And we will call our authentication manager.error description. And you might see that we have an error here because our error description is optional. So let's add a fallback, and inside of the string, we will write error trying to log in with credentials. Please try again. For the dismiss button, we will add the default button, and the label of the button will be a text that will say OK. However, note that it's possible to go even further by handling each error code that the evaluate policy function might throw. You can take a look at the LA error code and create a custom error description for each error code that the function might throw. As we want to keep this tutorial short and sweet, we won't go that far and only show an alert when we run into an error.